Here are all the questions that we are going to be doing in this functions exam question. So you can just take a look. Maybe you want to pause the video, but I'm going to be doing each question on a new slide just so we have a bit more space when going through. So here's the first set of questions that we're going to do. So we are told that we have this graph, f of x, okay, so that would be the parabola, and the parabola cuts the x-axis at B and D, C is the turning point, line E has an angle of inclination. Okay, so everything that they're telling us here is already shown on the diagram. So it says for the first question, write down the coordinates of B and D. So B and D are just your x-intercepts, right? So we can to find your x-intercepts, we know that we can just make y equal to 0. And so we're going to have f of x equals to x plus 4 and x minus 6. Now just stop here, because what a lot of learners would do now is they would first go multiply these two brackets together, and then they would end up factorizing again. And what will happen is you're going to end up right back at these brackets anyways. So we can actually just go straight to the answer now. We can make y equal to 0. And then we can simply say, therefore, x plus 4 must be 0, or x minus 6 would be 0. So x is equal to minus 4, or x is equal to 6. Now, when you give those coordinates, so you'll tell them that b is minus 4, but don't just say minus 4, say minus 4 and 0, and then tell them that d is 6 and 0. The next question says calculate the coordinates of C. Now there's a grade 11 and a grade 12 approach here. I'm just going to use the grade 11 approach, but for any grade 12 learners watching this, you can use calculus, and you can make your first derivative equal to 0 if you wanted to find this point over here. But as I mentioned, I'm just going to use the grade 11 approach, which is just to say that to find the x value of your turning point, you just use minus b over 2a. But now I do need to go and multiply this out first, so that I can see what my a, b, and c will be. So let's go multiply that together. So that's going to give us x squared minus 6x plus 4x minus 24. Then I can just neaten that up to become x squared minus 2x minus 24. And now I know what my a, b, and c are. So we can say that x is equal to minus b, so that's going to be minus, and then b is minus 2, over, and then it says 2a. And so a is just equal to 1. And so if you had to work this out, it's going to be 2 divided by 2, which is 1. Okay, so that's not the answer. That's just the x value of that turning point. To find the y value, you just need to plug that back into your equation. It doesn't matter where you plug it, though. You can plug it into this one, or you can plug it back into this original. It's all the same thing mathematically. So I'm just going to plug it into the very original equation. So that'll look like this. And so that's going to give us negative 25. So we can then fill that in here as negative 25. Then the next question says write down the range. Okay, so range is your y values, and you always want to go from small to big. So what that means mathematically is from the bottom to the top. Okay, so we always want to write our range from the bottom to the top. So we can say y is an element, and we're going from minus 25, which is included, and then these arrows just keep going forever and ever and ever, and so we're going to go all the way up to infinity. If you prefer to use set builder notation, you would say y is bigger than minus 25. You could actually just say that y is bigger than or equal to minus 25. Now we're on to the next question. So 7.4 says, given that theta is equal to 14,04. So let's fill that in over there. 14,04. And the tangent to f at t is perpendicular to AE. Okay, wait, what? Oh, the tangent at f. Okay, so let's draw in a little tangent to f at t. So we know that a tangent would be a line that would do something like that. Okay, so it's a tangent, so it only touches there at one exact point, and they've told us that that tangent is perpendicular to AE. So this is AE. So they're telling us here that this little angle here is 90 degrees. So they're saying, sorry, I've messed this up here with the marker location. There we go, I fixed that up. So that's 90 degrees. Now they want us to calculate the gradient of AE correct to 2 decimal places. Now this question's a bit weird, and I can tell you now that it annoyed some learners who wrote this exam or this question in an exam, and it might be annoying you right now because you're like, wait a minute, dude, why are we talking about angles and things like that when we are busy with paper 1? Isn't that part of analytical geometry? Well, yes, guys, sometimes they do a bit of an overlap. Sometimes you'll get a bit of paper 2 content in paper 1 content. So don't panic, okay? What I want to remind you of though is that whenever you get an angle, so let's go angle, I instantly want you to be able to think about gradient, because gradient can be converted into angle, and angle can be converted into gradient using tan. Remember, this has to do with like inclination angles and all of that. So think about that. Angle can always become gradient, and gradient can always become angle. And the way that you link them is by using tan. You know, like sin, cos, tan, but we specifically use tan. So if you have the gradient, then you can say tan of well, let's actually say if you have the angle, so you can say tan of the angle, that'll give you the gradient. And if you have the gradient one day, just in case, then you say shift. You say shift tan gradient. That's where that -1, it's shift tan. And that would give you the angle. So that is the link or the relationship between gradient and angles. Okay, so what this means is that if we know this angle over here, we know its angle above the horizontal. See, we've got that angle above the horizontal. So that technically means we could work out the gradient of that line. And it's easy to do, and that's why this is only 1 mark. So we would use this one here. So you would just say that the gradient of line AE is going to be tan of 14.04. Now they've chosen a really weird number, 14.04. So I have a feeling it's going to give us a perfect answer. Yeah, sort of. 0.25. It rounds off quite nicely. 0.25. Oh, and they did say correct to 2 decimal places. Okay, that's nice. So 0.25. Excellent. Now for 5 marks, this looks good. Calculate the coordinates of t. Now for this question, I'm going to show 2 different methods. There is a grade 11 technique on how to do this, which I think the grade 12 learners you should also watch. It's really good and you can use it and it's very good, it's like very helpful. And then I'll also show a grade 12 technique, which for the grade 11 learners, you must just ignore that one. So I'm going to start off with the grade 11 technique. Okay, so what you do is the following. What we must understand is that, okay, so if I have a parabola, now listen carefully, this is very valuable. If you have a parabola and you have a line going through the parabola, how would you find out where these 2 lines or these 2 graphs intersect? Well, you would make the 2 equations equal to each other, right? Okay, but how many solutions does this one have? Well, it cuts once and twice. So this one has 2 answers. Okay, what about this one? What if this line goes here? How many solutions would this have? Well, this would have no solution because these 2 don't even touch each other. Okay, now what about if it's a tangent? Let's draw that a little bit better. What if it's a tangent? Then in how many different places does it cut? Well, it only cuts once, so you only want 1 solution. Okay, now I'm going to show you a mathematical way of how you can find only 1 solution. So what I'm going to do, can we all agree that these 2 graphs, the tangent and the parabola, they are touching each other? So they are equal, they are going into each other. So how can you find out where the 2 graphs go into each other? You make them equal. So we're going to make f of x equal to the tangent's equation. Okay, but now we don't have the tangent's equation, but what we do know is the following. We know that the gradient of AE is equal to 0.25. right? They also told us that the tangent line and the line AE are perpendicular to one another. They are perpendicular. So we know that when two lines are perpendicular, when you multiply their gradients together, what do you get? -1. So I can then put the gradient of AE as 0,25, and I can try to work out the tangent gradient. If you had to go work out the tangent gradient, you're going to get -1 over 0.25, and that's going to give you -4. So now we know what the tangent's gradient is. So therefore, the gradient of the tangent is -4. So what is the equation of the tangent? Well, it's y equals to mx plus c. So we can say y equals to -4, because that's the gradient, plus c. We don't know what c is yet, but that's okay. That's fine for now. So what we're going to do now is we're going to make the parabola equation equal to the tangent's equation. So that's going to be x plus 4 times x minus 6, because that's the parabola, and you're going to make that equal to the tangent. Okay? Then I just want you to get everything to the one side. So let's quickly go multiply all of this out. And then we're just going to put all the like terms together. Okay, now when I solve this equation, that is going to tell me all the different places where the tangent is touching the parabola. Why? Because I made them equal to each other. Remember that. I'm trying to see where is the parabola equal to the tangent. That's what we're trying to figure out here. Where is the tangent equal to the parabola? But I only want the answer. How many answers do we want, guys? Do we want the tangent and the parabola to touch each other 0 times, once, or twice? Like, do you want it to touch in 0 places, 1 place, or 2 places? Well, because it's a tangent, you only want it to touch in 1 place over there. Just once, okay? So, as we said, we only want the tangent to touch the parabola once. So we only want this equation, when we solve it, we would only want it to have one answer. So you might be thinking, okay, Kevin, I understand, but how do we make it so that it only has one answer? Well, this is where we come back to nature of roots. Why? Because if we can make this the discriminant, or the b squared minus 4ac, if we can make that equal to 0, then what we used to call that was equal roots. Equal roots. Now, what does equal roots mean again? It means like maybe your answers will be x equals to 3 or x equals to 3. That is what we mean when we say equal roots. So can you see that that actually means that there's only one place? Haha! So what we're going to do is we're going to go find the discriminant of this thing over here. Remember, your discriminant is the b squared minus 4ac, and we want that to be equal to 0, because that is meaning one root, or only one type of root. Okay? So your b value is going to be a 2. So we'll say 2 squared. Now a is 1. Now be careful, c is not this c. That's just a coincidence. C is all of this. Okay, so we're going to say minus 24 minus c, and you're going to make that equal to 0. So this is going to allow us to find c. So I'm going to solve it here. So we're going to say 4 minus 4, and then in brackets we still have this. So then I'm going to multiply the 4 in, so that's going to become 96, 24, 48, yeah, 96, and then plus 4c. There we go. Now, if you had to go calculate c, you should eventually get minus 25. So that means that that tangent is going through the y-intercept, or it's got a y-intercept at minus 25. Okay, so that's really nice, because now we know the value of c for that tangent. So this isn't the answer, but we close now. So now we can say that the tangent is y equals to minus 4x minus 25. Now that we know that, now we can just make the two equations equal, and it will tell us exactly where the two graphs cut. So we can make the parabola and the tangent equal to each other now, because now we have the tangent equation. We didn't have the tangent equation earlier because we didn't have its c value. Now we do. So I'm just going to quickly multiply this parabola out again, like that. And then I'm going to take everything to the left-hand side, and that's going to give us +1. Yeah, this is beautiful, because now if you had to go factorize this, check this out, you're going to end up with x plus 1 and x plus 1. Haha. So we're going to get one answer, x equals to -1. So it means that the tangent is only touching the graph at -1. And then to find the y value, because that t is on both, you can plug that y value into the tangent's equation or into the parabola. It doesn't really matter. I'm going to use the tangent, and so I'm going to plug the x value of -1 into that, and this would give us -21. So the y value here is -21. So the final answer is -1 and -21. Now, for the grade 12 learners, okay, this is for the grade 12 learners now. If you're a grade 11 learner, trust me, you don't need to know this part. So you can just click, 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 and fast forward until you are onto the next question, which I think would be, 7.5. Okay, so you can just go ahead now. Trust me, this is not going to be helpful for you. Even if you're a student who does AP maths and you're like, yeah, no, but I know this, like, I can do grade 12 maths. Trust me, it's a waste of your time. If I was you, I would just go to 7.5. All right. Look, if you feel like you need a bit of a break and you need to procrastinate a bit and you're interested to see how we do it in grade 12, by all means, I'll welcome you. So, but if you're pushed for time, you can go ahead. Okay, so for the grade 12 learners, it's actually going to be a little bit easier because we know about tangents in the section of calculus. So we know from grade 12 calculus that all grade 11 AP learners like, calculus, like easy stuff. So I didn't do AP maths, by the way, guys. I've got some AP maths learners that I've helped now, but when I was in school, I matriculated in 2011, so we didn't actually have AP maths back then. We had Cambridge maths, but I didn't do that either. I just did normal pure maths. So, but the AP maths stuff, it's pretty crazy. It's quite challenging. I did study engineering, so I did do a lot of that type of maths in my engineering degree, but yeah. I don't know where my story is actually going right now. So I think we should carry on. So for grade 12, you guys know that the gradient of a tangent is always the same as the gradient of the graph. You know, at the point where they contact each other. So let's actually scratch this out, because let's pretend we don't know what that answer is. So at this point of contact, we should remember that the gradient of the tangent is the same as the gradient of the graph. And how do we get the gradient of a graph? Well, in grade 12, we now use calculus, and we know that that's from the first derivative. That's what gradient means. So to find the gradient of a parabola, you take the first derivative. Now, from the grade 11 approach, we already worked out what the tangent's gradient is, but maybe you didn't watch that. Maybe you jumped straight to the grade 12 method, because you ain't got no time for that. So maybe I need to show you how we get the gradient of the tangent once more. So that's pretty easy. So we know that when two lines are perpendicular or at 90 degrees, which they told us here, then we know that when you multiply their two gradients, so if you multiply the gradient of AE multiplied by the gradient of the tangent, then you get -1, because that's perpendicular, right? So the gradient of AE is 0.25, and the gradient of the tangent is the one that we're trying to calculate quickly. So if you had to go work out the gradient of the tangent here, you would get -4. Okay, so we have the gradient of the tangent, which is fantastic. So we can say -4 over there. Now we need to take the first derivative of f. So let's first multiply this out quickly just to get it looking nice. That would eventually give us this. Okay. So to take the first derivative, whoa, what happened there? to take the first derivative, we have to take the first derivative. I don't know what I'm trying to say there. So that becomes 2x minus 2. So I'm going to put here 2x minus 2. Okay, see how easy this is. It's much better than the grade 11 approach. Okay, so now we're just going to go solve this equation, and so we're going to end up with 2x equals minus 2, and so x equals minus 1. So that means that this contact point over here, the x value is minus 1. Now to find the y value, you can simply plug that x value into the original parabola equation, because we know what its equation is, and that'll give us the y value. So we can just go plug in that minus 1 into the original equation, and if you had to go do that, that would give you negative 21. And so we can fill that in here, negative 1 and negative 21. So there we go. I've showed you the grade 11 method and the grade 12 method. Let's move on. So here's this one. It says that a straight line, which is G, which is parallel to AE. Okay, so parallel to AE is like that, or that, or that, or that, or that. You know, that's what parallel is. And it says that it cuts the graph F at minus 3, minus 9. So let's try to predict where that is. Minus 3, minus 9. Maybe you want to pause, but that's somewhere here, right? Minus 3, minus 9. So it's a line that's parallel, so it's going something like that. So this would be, it says it touches it at K, which is minus 3, minus 9. And then it cuts it again at R. So this would be R. That would be R over there. Okay, so this is not a difficult question at all. The reason is if we can work out the equation of this line, then we can simply make that equation of this line equal to the parabola, and it will tell us where what these 2 points are. So let's go work out the equation of KR. So our goal, you don't have to write this in the test, but our goal is to find equation of KR. Okay, now we know that it's a straight line, so that's y equals to mx plus c. We already know its gradient. Remember, the gradient of AE was, from an earlier question, we said 0,25. So the gradient of KR is equal to 0,25. Why? Because KR is parallel to AE. We know that. They've told us that. So therefore we can say y equals to 0,25x plus c. Now to find c, we have to plug in a point on this line. But that's okay, because we have the coordinates of k. So we can just plug in minus 9, minus 3, and then we can go calculate the value of c. And if you do that, you would find out that c is minus 8.25. So therefore, the equation of KR would be y equals to 0,25x minus 8,25. Now we know the equation of this line, so we can simply make it equal to the parabola, and that'll tell us K and R. We already have K, but that's okay. Haha. So let's go do that. We're going to make the two equations equal to each other now. So we can say 0,25x minus 8,25, and we can make that equal to the parabola's equation. I'm just going to multiply the parabola's equation out for the 74th time in this question. There we go. And now we can simply do our thing. So we can move everything to the one side. You guys know all of this by now. Okay, and then we can put everything together. Definitely going to use the quadratic formula here, hey guys. So this is minus 15.75. Okay, so now we are going to use the quadratic formula, this one. Now some learners always ask me, should I plug in the values? Do the teachers want to see that? And the answer is yes, show them that. So the minus b, so there's a minus there, and then the minus is, the b is also minus, so I show it like that. Then you can just say plus minus, and then you're going to put the thing in brackets here. Must be in brackets, very important there. Just put everything in brackets, actually. Brackets will never make it wrong. Minus 15.75 over 2 times A is 1. Now, we're hoping that one of our answers is minus 3, because we know that they do cut each other at minus 3, but we want the other one. So if we don't get minus 3, we know that something's gone a bit funky. Okay, so if you had to go plug this in on your calculator, the two answers that you should get will be minus 3, haha, so we know it's correct, and then the other one is 21 over 4 or 5.25, and they just want the x coordinate of r, so we don't have to go find the y value, and so that is the answer, 5.25. So in the test you would say, you'd put a little line through that one, because you're just telling the teacher that it's not that one.